Okay, we're still covering section 2.1 and 2.2 in this video here. So we're talking about equations of lines, and I've got a handout here. There's two forms of equations of lines that we have to know. The slope-intercept form is y equals mx plus b. M is the slope and b is the y-intercept. We've already very briefly looked at that form already, but that's a common form that we'll give our answers in. And then there's the point-slope form. It says the point-slope form of an equation of a line with slope m and passing through the point x1, y1 is y minus y1 equals the slope times x minus x1. Okay, so problem 1, they want us to find an equation for a line containing the point 0, 16 with a slope of negative 7/9. And we'll write the answer in slope-intercept form. Okay, a couple of things. So first of all, anything with lines, always give the answer in slope-intercept form. Like you're not done with the problem until you're in the form y equals mx plus b. Okay? So this line has a slope of negative 7/9 and a y-intercept at 16, right? Because how you find a y-intercept, you gotta let x be 0. So the point 0, 16, that's actually the y-intercept. Okay, and so that means I can go right to the answer. I'm going to have y equals negative 7/9 x plus 16, or y equals mx plus b. Okay, circle that result. And here's another problem. So problem 2, it says to find the slope and the y-intercept for the equation 2x minus 6y minus 13 equals 0. Okay, now that equation is in standard form. Standard form is not a common form for lines, okay? Really, it's just slope-intercept form and point-slope form. Those are the two common forms there. So I want to find the slope and the y-intercept. Let's go ahead and get this equation into slope-intercept form. Okay, so solve for y. If we add 6y to both sides, 6y is equal to 2x minus 13, and then divide by 6. So y is equal to 2 over 6 1/3 times x minus 13/6. Looks like the slope is 1/3, and the y-intercept, or the b value, would be negative 13/6. Okay. Problem 3, we want to find an equation for a line containing the point 1/2, negative 1, and having a slope of 5. Write your answer in slope-intercept form. Okay, now this problem is different from problem 1, because in problem 1, like I could just go right to the answer, because this point that was given to me was the y-intercept. The point 1/2, negative 1, that's not the y-intercept. Okay, so there's going to be a little bit more work to do here in this problem. Let me begin by using the point-slope equation. Okay, I know a point on the line and I know a slope. So y minus y1 is negative 1 equals the slope is 5 times the quantity x minus 1/2 is x1. Okay, and then I need to solve for y. So I need to get this in the slope-intercept form. Y plus 1 is equal to 5x minus 5/2, and if I subtract 1 from both sides, y is equal to 5x minus 7/2. That'd be the answer there. Okay. By the way, another way that you could do this problem is like we know a point on the line and we know the slope. So we just need to know the y-intercept, right? So I could, if I wanted to, go right to the point-slope form, and or right to the slope-intercept form, and say negative 1 equals y equals m is 5 times x is 1/2 plus b. And then I solve this equation for b. So I need to subtract 5/2 from both sides. Negative 1 minus 5/2, that's negative 7/2. Okay, so the slope is 5, the y-intercept is negative 7/2, and then I can go to the answer. Okay. Now the point-slope equation is an important kind of an equation for a line, so I would like you to know that one. But there are some ways of getting around that equation, like we see here. Okay. Problem 4, it says to write the slope-intercept equation for a line containing the points -2, 7, and 4, -8. All right, so the first thing that we have to know is the slope of the line. So change in y over change in x. x1 is -2, y1 is 7, x2 is 4, and y2 is -8. So the difference in the y values, I'm going to say -8 minus 7 divided by the difference in the x values, that'd be 4 minus a -2 is the same as 4 plus 2. Okay, so I get -15 over 6, and that reduces, right? 3 is going to go into both those numbers evenly. So 3 times -5 is -15. 3 times 2 is 6, so it'll be -5 halves. Okay, by the way, always reduce the numbers if you have something that reduces, or always simplify your answers for any problem. Okay, keep that in mind. So then the next thing is I know a point on this line. Actually, I know 2 points on the line. I know the slope. Okay, so let's go ahead and use the point-slope form. It doesn't matter which point we select. Both of them are on the line. Right, so why don't I just use this point, -2, 7. Y minus y1 is 7 equals the slope is -5 halves times x minus -2, the same as x plus 2. Okay, and then we need to solve for y. So y minus 7 is equal to -5 halves x minus 5, the 2's cancel. And then if I add 7, y is equal to -5 halves x plus 2. Okay, and go ahead and circle that equation there. In problem 5, we want to write the slope-intercept equation for a line if the x-intercept is -6 and the y-intercept is -8. Okay, so by them telling me that the x-intercept is -6, that means that the point -6, 0 is on the graph, right? Because how you find an x-intercept, you need to let y be 0 to get x. And how do I find a y-intercept? I need to let x be 0 and get y. Okay, so 0, -8 would be another point on this line. So this problem is just like the other one, just like problem 4 here that we looked at. I need to know the slope of the line, right? So change in y over change in x, that's going to be -8 minus 0 divided by 0 plus 6. It gives me -4/3. And I simplify that. Okay, so then the next thing is I could use the point slope form, or at this point I can go right to the answer. Because 0 and -8, that's the y-intercept. Right, and I know the slope. So y is equal to -4/3 x minus 8. That's the answer. And I can also get the same answer by using the point slope equation. Okay, either way. Okay. Go to the next page there. So on this next page, I'm talking about parallel and perpendicular lines. It says that two lines are parallel if their slopes are equal and they have different y-intercepts. Two lines are perpendicular if their slopes are -1. So that is, perpendicular lines have slopes that are called negative reciprocals of each other. All right, problem 6 is where they want us to determine if the two lines are parallel, perpendicular, or neither. Okay, part A, I got y equals 7x minus 9 and y equals 1/7 x plus 3. Well, those lines are not going to be parallel, right, because they got different slopes. One is a slope of 7, the other is a slope of -1/7. They're also not going to be perpendicular either because the slopes are not negative reciprocals of each other. They're reciprocals. They're not negative reciprocals. So if I take 7 times 1/7, I don't get -1. Okay? So that would be neither. In part B, I have y equals 5/3 x minus 2 and y equals 5/3 x minus 7. So those would be parallel lines because the slopes are the same number. Okay. Part C, I got y equals -2x and y equals 1/2 x minus 8/5. So those lines would be perpendicular to each other because the slopes are negative reciprocals of each other. Okay. In other words, if I take a -2 times 1/2, that gives me -1. Okay. So I got perpendicular lines there. Part D, we have f of x equal 4 and then f of x equal 4x minus 11. So the first line, y equals 4, y and f of x are the same thing, remember. Y equals 4, that'd be a horizontal line. Horizontal lines always have a slope of 0. So this line has a slope of 0, and this other line, y equals 4x minus 11, that has a slope of 4. Okay, so they're different slopes, right? They're not negative reciprocals of each other, right? Because if I take 0 times 4, I don't get -1. So they're not perpendicular also. Okay, these lines would be neither parallel or perpendicular. In part E, I have y equals 4/7 x plus 2 and y equals -7/4 x minus 3. Okay, those would be perpendicular lines because the slopes are negative reciprocals of each other. If I take 4/7 times -7/4, I end up getting -1. Okay. Part F, I have the lines y equals 3x minus 5 and y equals -3x plus 1. So these lines are not parallel, right? Because the slopes are different numbers. One has a slope of 3, the other has a slope of -3. They're also not perpendicular because the slopes are not negative reciprocals of each other. In other words, if I take 3 times -3, I don't get -1. I get -9, right? So that would be neither, would be the answer. 3 and -3 are opposites of each other. They're not negative reciprocals of each other. Okay? So in order to have perpendicular lines, you got to have slopes that are negative reciprocals. Okay. Why don't we go ahead and stop the video right here, and I'll pick up with problem 7 then in the next video.